have a quick recap. Okay, so last day what we discussed about resolution of vectors. In resolution of vectors আমরা কি ডিসকাস করলাম কি যদি আমার কাছে if I have say a vector lying in 2 dimensions, हमारे पास एक वेक्टर है which is lying in 2 dimensions. Suppose this is my x axis and this is my y axis. If I have a vector A like this, if I have a vector A like this, right? So what we can do, we can express it as sum of 2 vectors. हम लोग ये सोच सकते हैं कि it is basically the sum of 2 vectors, one lying along the x-axis, one lying along the y-axis. तो जो vector along the x-axis होगा, it will be written as some number ax multiplied by I cap, and the vector along the y-axis will be written as some number ay multiplied by j cap. So we write a vector as ax I cap and ay j cap. यहाँ पे हम लोग ax and ay को क्या बोलते हैं? The x and y components of vector है. Yes or no? These are called x and y components of vector A. And this I cap and j cap are what? Unit vectors along x and y axis respectively. ठीक है, तो I cap is the unit vector along positive x direction, j cap is the unit vector along positive y direction. ठीक है, and we also discussed कि कभी भी अगर कोई भी वेक्टर इस फॉर्मेट में दिया हुआ है, then the magnitude of that vector will be equal to what? Square root of the coefficient of I cap, that is ax, and square of the coefficient of j cap, that is ay, right? And if the vector is making angle theta with the x-axis, so what will happen? The x component will be equal to magnitude of a into cos of theta, and the y component will be equal to magnitude of a into cos of which angle? 90 minus theta. Because if it makes theta with x, it will make 90 minus theta with y. So that will be equal to a sin theta. Yes or no? So this means we can say that tan of theta will be equal to the y component divided by the x component. So these are the important points regarding resolution of vectors, right? So resolution means हम एक वेक्टर को as a sum of 2 vectors दे सकते हैं या 3 vectors दे सकते हैं based on the case. तो 2 dimension में 2 vectors होगा, 3 dimension में 3 vector होगा. ठीक है? And remember कि using resolution we can split up motion in 2 dimension or motion in 3 dimension as what? Sum of motion along x-axis and y-axis, or along x, y, and z-axis separately. That was the idea of resolution. ठीक है सर? So this was the last discussion. तो हम लोग क्या करेंगे आज today, using the resolution of vectors, we will try to discuss about projectile motion. Projectile motion मतलब projectile means what? Suppose if I throw a ball, ठीक है? Suppose if you throw a ball in air, if you throw it straight up in air, क्या होगा? It will go straight up, it will reach a highest point and it will fall downwards. But if a ball is thrown, okay, from or with at some angle, तो क्या होगा? The ball will move on a curved path and it will land up on the ground somewhere, or it will land up on the same level. ठीक है? This kind of an object is known as a projectile. ठीक है? So let us see how we can analyze motion of a projectile using resolution of vectors and using the idea of motion in a straight line. Motion in a straight line हम लोग already पता है. Yes or no? What is velocity? What is acceleration? Right? How we write the equations of motion and all that. Okay. So now, before we go to resolution of vectors and use of resolution of vectors in projectile motion, so let us just have a quick recap of equations of motion. तो हम लोग को क्या पता है? We know that for uniformly accelerated motion, for uniformly accelerated motion, हमने देखा था कि we can relate velocity, position, displacement by some equations, and these equations are called equations of motion. तो पहला equation of motion क्या था? V equals to U plus A T, right? इसका नाम क्या था? This was called velocity time relation, है तो? This was known as velocity time relation. ठीक है? Now you know that any vector can be written as the sum of two vectors in a plane. So in place of V, we can say Vx I cap plus Vy j cap. Yes or no? In place of U, we can write Ux I cap plus Uy j cap. In place of acceleration, we can write Ax I cap plus Ay j cap into T. ठीक है, तो अगर हम उसको ब्रेक करें तो क्या मिलेगा? देखो, मिलेगा यू एक्स आई कैप प्लस ए एक्स इंटू टी आई कैप प्लस यू वाई जे कैप प्लस ए वाई इंटू टी जे कैप. Yes or no? So if you collect the terms, you can say it will be ux plus axt into I cap plus uy plus ayt into j cap. Understood? So now if you equate the left hand side and right hand side, so what you can say? You can say Vx will be Ux plus Axt, whereas Vy will be equals to Uy plus Ay. Understood? तो जो इक्वेशन हम लोग लिखते थे v इक्वल टू यू प्लस ए टी इन जनरल, हमने क्या किया? उसको दो पार्ट में ब्रेक कर दिया. One for motion along the x-axis, one for motion along the y-axis. ठीक है? Understood? राहुल समझ में आ रहा है?
Yes, sir.
तेरे following? Done? अच्छा. What was the next formula? याद करो, next formula क्या था? What was the second formula? S equal to T plus half A T square. Right? Remember, कि S is a vector, U is a vector, A is a vector, T is not a vector. इसलिए हमने S के ऊपर vector symbol दिया. अच्छा, what is S? Displacement. And you know, displacement means what? Displacement means change in x coordinate multiplied by I cap plus change in y coordinate multiplied by j cap. Last दिन बताया था ना, displacement vector. What is it? x2 minus x1 I cap plus y2 minus y1 j cap. बताया था? ठीक है? Same way, u क्या होगा? ux I cap plus uy j cap. a क्या होगा? ax I cap ay j cap. ठीक है, तो once again collect the terms together, तो क्या मिलेगा? x minus x0 I cap plus y minus y0 j cap. क्या बन जाएगा? देखो, I cap का सब टर्म्स कलेक्ट करो. तो फर्स्ट ब्रैकेट में व्हाट इज द कोफिशिएंट ऑफ I cap? ux into t. Yes or no? सेकेंड टर्म में व्हाट इज द कोफिशिएंट ऑफ I cap? half ax and t square. Understood? Just like the previous case. Same way, coefficient of j cap in the first term is uy into t. And what is the coefficient of Jacob in the second one? Half ay t square. Right? Now just collect the terms together. So what you can say? The x minus x0 will be uxt plus half axt square. This will be for motion along x-axis, and y minus y0 will be uyt plus half ayt square. This is for motion along y-axis. So again we are doing what? We are splitting up. So displacement time relation था s equal to ut plus half at square. We are splitting up it into two displacements, one along x-axis, one along y-axis. तो जे কোনো ভেক্টরকে দুটো পার্টে ভাঙা যায়, ঠিক আছে? একটা along x, একটা along y, ঠিক আছে? Understood? So if I call these two sets of equations as equation say 1, set 1, and these two as the set number 2, so from 1 and 2 what we can say? अगर मैं t को eliminate कर दूंगा, so from 1 and 2 what we'll get? We'll get v square minus u square. Vx square minus ux square equals to 2ax x minus x0, and vy square minus uy square equals to 2ay y minus y0. ये कौन सा फॉर्मूला बना? v square minus u square equal to 2as वाला फॉर्मूला. This is the third step. Understood? So whenever we want to describe motion in a plane, हमें क्या करना है? हमें देखना है, we have to represent it as what? Motion along x-axis. उसके लिए हम लोग left वाला equations use करेंगे, x वाला equations use करेंगे, and we have to see it as motion along y-axis. For that, we'll use the equations on the right, having the coefficients y. Understood? So this is the basic idea how we have to analyze any motion in a plane, be it projectile motion, circular motion, or any kind of planar motion. Rahul, clear one?
Yes, sir.
Finished? Done? अभी आगे पार्ट गुलो ना वही रूपेश दा का जिज्ञास করে নিস রেকর্ডেড লেকচারস है उसको दे दीजिएगा, ठीक है? लिंक छोड़ा, ओके? रिवाइज করে শোন থেকে দেখে বুঝতে পারলি? যেগুলো প্রবলেম হবে আমাকে বলবি. So using this now we are trying to explain something known as projectile motion. Want to express about projectile motion. So first of all, we want to find out, we have to know what is the meaning of a projectile. Okay, what is the meaning of a projectile? So remember that a projectile is any such object. Projectile is any such object which after being projected or thrown, after being projected or thrown, moves under the influence of gravity only, and is not by ठीक है? तो अगर मेरे पास कोई ऐसा ऑब्जेक्ट है which after being thrown or projected moves only under what? gravity, no other force is affecting it, no other force is propelling it, pushing it, then we can call that object as a projectile. For example, a cricket ball thrown by a bowler is a projectile because once it is thrown, then it will move only under gravity. ঠিক আছে, ধর রাস্তার পাশ দিয়ে যাচ্ছিস, একটা আম গাছ আছে, পাথর দিয়ে ছুঁড়ে মারলি আম, so that piece of stone is also projectile. আমটা এসে মাথায় পড়লো, that is also projectile. Understood? So all these are examples of projectile, right? या मान लो बाहुबली मूवी देखा है, हाँ बाहुबली मूवी में ऊपर से काल के आर्मी के ऊपर फेंकता है, ठीक है, that shells, that is also a projectile. Why? It is also moving only under gravity. So once after we show it, we project it, if it is moving only under gravity, then that can be called as a projectile. Okay? So remember that in the simple model of projectile, in the simple model of a projectile, we assume that the heights involved are small, so that the object moves with constant acceleration due to gravity. Simple models of projectile may we assume that the heights are small. Small matlab small as compared to radius of Earth, या radius of the planet. Now how much is radius of Earth? 6,400 kilometer. यानी अगर मैंने किसी ऑब्जेक्ट को 1 किलोमीटर हाई ऑब्जेक्ट से भी फेंका, 1 किलोमीटर हाई इज नॉट स्मॉल, 1000 मीटर हाई इज अ बिग हाइट, राइट? तो अगर तुमने 1000 मीटर का टावर भी लिया, उसके ऊपर से भी कोई ऑब्जेक्ट को थ्रो किया, दैट इज ऑल्सो अ स्मॉल हाइट. Why? Because as compared to the radius of Earth, it is very, very small. ठीक है, तो whenever the heights involved are small, acceleration due to gravity can be taken as constant. तो हम लोग क्या assume करेंगे कि projectile motion is motion with constant acceleration. पढ़ना है क्या? एक्चुअली इन रियलिटी एक्सेलरेशन ड्यू टू ग्रेविटी कांस्टेंट है? नहीं है. जितना हम ऊपर जाते हैं एक्सेलरेशन ड्यू टू ग्रेविटी कम हो जाता है. एज वी गो अपवर्ड्स एक्सेलरेशन ड्यू टू ग्रेविटी डिक्रीजेस, बट वी आर अज्यूमिंग स्मॉल हाइट्स so that the decrease is negligible, so we can assume that it remains almost constant. Understood? So we can say projectile motion is a uniformly accelerated motion. और कौन सा acceleration है? Acceleration due to gravity. Clear? Okay. Generally, we can say that generally a projectile moves in the vertical plane. Projectile moves in the vertical plane. Vertical plane matlab like air, right? If you throw something in air, it is moving through air, it is a vertical plane. Okay? If I throw an object, it is moving over the wall, that is also a vertical plane. Okay? So generally a projectile moves in the vertical plane. Okay, and we assume horizontal direction. We assume the horizontal direction on the x-axis and the vertical direction along the y-axis. Vertical direction along the y-axis. ठीक है. अब मुझे बताओ कि यहाँ पे ऑब्जेक्ट का जो एक्सेलरेशन होगा वो किस तरफ होगा? Along x or along y? Along y only, because gravity is acting only along the vertical direction. Therefore, we can say in projectile motion, acceleration along x-axis will always be. projectile motion है, along x-axis কোনো acceleration থাকবে না, along horizontal direction the object will always move in a uniform motion, in a straight line. Clear? Understood? Right? And the component of acceleration on y will be equal to what? Plus or minus g. ঠিক আছে? Plus minus depends on what? If you take upward as positive, then g will be negative downwards. And if you take downward as positive, it will be plus g. Depends on your choice. Understood? So plus or minus depends on the direction that you have selected, but it will be along the y-axis. Right? So remember that plus minus g, but g is always downwards. Always vertically downwards. ঠিক আছে? Fine. So now let us try to understand what are the different types of projectiles possible, and अगर मुझे projectile motion दिया हुआ है, मैं कैसे उसको mathematically express करूंगा? How will I predict कि मेरा projectile कितना दूर जा सकता है, वो कितना speed के साथ ground को hit करेगा, and all these things. How can we find it out? ठीक है? So for that, the first assumption, first case, यहाँ तक clear है सबको? राहुल यहाँ तक clear हुआ?
Yes.
Okay. So the first case of projectile motion is known as a horizontal projectile. The horizontal projectile, if you project anything, if you throw anything from a height horizontally, then it is called a horizontal projectile. So say for example, this is my ground level. Okay, this is my ground level. We have a tower, suppose, or some tall object on it. This tower is having a height h. Okay, and from the top of the tower, we have projected some object like a ball or something straight with a velocity u. The projectile is known as a horizontal projectile. So ये जो velocity है u, which will be u along I cap only, क्योंकि what we are assuming that the horizontal direction is x-axis, बताया ना अभी, and vertical direction is y-axis. अच्छा, এবার যখন আমি বলটাকে এভাবে ধর ফ্লিক করব, suppose this pen is kept, if I flick it, what will happen? It will go straight and go down. উপরে তো যাবে না. So the vertical will be only downwards. So let us take the downward direction as positive y. Understood? You can take the downward as negative y also, but there is no need of taking negative. কেন তো নেগেটিভ দিকে যাবেই না, ও একদিকেই যাবে নিচের দিকে, তাই না? So that is why we will take this direction as the y-axis. Understood? Now in book you may find it is taken as minus y. Doesn't matter. If you take y, if you take minus y, only the form of equation will change, but meaning of equation will remain same. Understood? So horizontal is taken as x-axis, vertically downward is taken as y-axis. So u will be along which direction? I cap direction. So we can write it as u I cap plus 0 j cap. Because j cap had no component in it. That means what? That means the x component of initial velocity is u and the y component of initial velocity is c. Acha. We know that here projectile motion means acceleration will be downward. Downward ta kon dike niyechi here y-axis. So we will write g multiplied by j cap. And as there is no I cap, I can write it as 0 I cap also. That means what? Along the x-axis, acceleration is 0. Along the y-axis, acceleration is g. Acceleration due to gravity. ठीक है, these are the points that we have to remember. Clear? ये जो वेलोसिटी हमने लिखा है यहाँ पे u, this velocity is known as the velocity of projection. This is called velocity of projection. जिस वेलोसिटी के साथ हम थ्रो करते हैं उसका नाम क्या है? वेलोसिटी ऑफ प्रोजेक्शन. एंड द पॉइंट फ्रॉम विच वी थ्रो, O, is known as point of projection. O is known as point of projection. ठीक है, तो लेट अस अज्यूम कि आवर पॉइंट ऑफ प्रोजेक्शन इज 0,0, मतलब x कोऑर्डिनेट इज 0, y कोऑर्डिनेट इज आल्सो 0. ठीक है, नाउ suppose after some time, after a time t, say my particle has reached here at the point P, whose coordinates are x comma y, whose coordinates are x comma y. So let P having coordinates x comma y be the position of the particle or be the position of the projectile after time t. Okay, or after an interval of time t, after it is projected. Right? Clear? So, for motion along x-axis, what can we say? अभी मैंने बताया, if I want to find the relation between position and time, कौन सा इक्वेशन यूज करेंगे? S equal to ut plus half a t square. और उसका x कंपोनेंट क्या था? x minus x0 equals to, क्या लिखते थे हम लोग? याद करो, x minus x0 equals to uxt plus half ax t square. Yes or no? तो यहाँ पे आफ्टर टाइम t कोऑर्डिनेट कितना है? x है. इनिशियल कोऑर्डिनेट मैंने कितना लिया था? 0 लिया था. पॉइंट ऑफ प्रोजेक्शन हैज बीन टेकन एज 0. x कितना है? u है. और ax कितना है? 0 है. That means we will write x will be equal to u into t. This is our equation number 1. ठीक है? Same way, for motion along y-axis, what can we say? We can say y minus y0 equals to uyt plus half ayt square. Right? Same way, y minus y0 uyt plus half ayt square. तो y हमारा कोऑर्डिनेट है. इनिशियल y कोऑर्डिनेट भी 0 ही था. What was the initial velocity along y-axis? This was 0. And what was the acceleration along x-axis? It was g due to gravity. So ultimately keep along y equal to half gt square. This is equation number 2. Right? So motion along x-axis is what? Motion in a straight line. Motion along y-axis is free fall. That means अगर मैंने इस पेन को यहाँ से फ्लिक किया तो क्या होगा? हॉरिजॉन्टली ये स्ट्रेट मूव करता रहेगा, बट वर्टिकली ये फ्री फॉल करता रहेगा. That is why ultimately it will come down. Understood? It will try to go straight, then go down, straight and go down. That is why it will follow a curved path. Clear? So let us first find out what is the equation of trajectory of the projectile. Equation of trajectory. Trajectory means path. Which kind of path will it follow? Which shape of path will it follow? Remember, कभी भी अगर तुम्हें क्वेश्चन में बोला जाए इक्वेशन ऑफ ट्रैजेक्टरी मींस वी हैव टू रिलेट y with x. We have to relate y with x. t को एलिमिनेट करना है. तो from equation 1 we can write, t will be x upon u. right? And if you put that in equation 2, क्या मिलेगा? Y equals to half G T का square मतलब X by U का square. So that will give us Y equal to G X square by 2 U square. This is the equation of the projectile. इसका मतलब जब x 0 है तो y कितना है? 0 है. जब x 1 है तो y कितना है? g by 2 u square. x 2 है तो y कितना है? 4g by 2 u square. x 3 है तो y कितना है? 9g by 2 u square. That means if I take the units of g by 2 u square, तो 0 पे 0 होगा, 1 पे कितना होगा? 1, 2 होगा, 4 and so on. So if you join all these points, you will get a curve. And ये जो curve है, right? This kind of a curve that we have got here, where the point P lies, this curve is known as a parabola. क्या बोलते हैं इसको? Parabola. Remember that y equal to gx square by 2u square is equation of parabola. That means the projectile will follow a parabolic path. What is the shape of the path? Parabolic. Clear? Whenever y is proportional to x square, तो ग्राफ कैसा बनता है? पैराबोला. So we can say that the path will be a parabolic path. ये जो शेप, ये जो कर्व बना, this curve is known as a parabola. ठीक है सर? ঠিক আছে, বুঝতে পারিস, অসুবিধা হচ্ছে? গরম লাগছে? ओके. अच्छा, अब नेक्स्ट जो पॉइंट है, राहुल समझ में आया यहाँ तक? तो
Yes.
right. So remember, if you know these two formulas properly, माने equation of path and motion along x-axis, motion along y-axis, अगर ये तीन फॉर्मूला अच्छे से याद है, तो you can find out many things. What are the things? We'll see now. कि इस चीज से हम लोग क्या क्या find out कर सकते हैं? What things we can know about? ठीक है? प्राप्ति finish writing? Finish writing? Done? Okay. So first of all, let us try to find out what will be the time of flight of the projectile. Let us try to find out the time of flight. We will represent the time of flight by symbol capital T. Time of flight मतलब कितना टाइम के लिए वो फ्लाई कर रहा था? फ्लाई कहां से कहां तक कर रहा था? From the point of projection to the ground, जहां पे उसने ground को hit किया, right? So we can say that for t equal to time of flight, जो vertical displacement होगा, that will be equal to h. Yes or no? Diagram को देखो, see the diagram. I have thrown it from the point O. It is hitting the ground at the point, suppose let's call this point as G. तो O से G पे आने के लिए जो टाइम लगेगा, that is the time of flight. And during this entire time, vertically उसने कितना move किया? H distance move किया. So I can say that for small t equal to time of flight, y will be equal to h. But we know that y was equal to half gt square. Yes or no? That means we can say h will be equal to half g into capital T square, means capital T square will be 2h upon g. That means T will be root over of 2h upon g. That clear? That means for a horizontal projectile, for a horizontal projectile, the time of flight is independent of the speed of projection. कितना स्पीड के साथ मैंने उसको थ्रो किया, टाइम ऑफ फ्लाइट विल नॉट डिपेंड अपॉन दैट. अगर मैंने उसको ड्रॉप किया होता, then also whatever time of flight will be there. If I throw it with a large speed, then also time of flight will be same. বুঝলো? যদি আমি ধর এই ডাস্টারটাকে এখান থেকে ড্রপ করি আর পেনটাকে এখান থেকে ফ্লিক করি একসাথে, দুটো গ্রাউন্ডে একই টাইমে গিয়ে হিট করবে। বুঝলো? Not at the same place. This will drop here, this will go further, but time of hitting the ground will be same. ঠিক আছে? So time of flight does not depend upon the initial speed given. The next point that we will try to find out is called horizontal range. We will represent it by the symbol R. मतलब प्रोजेक्टाइल कितना दूर जाएगा, बाहुबली वाला सीन. ठीक है, पहले क्या बोलते हैं, शेल फेंकता है फिर पर्दा लगा के. देखा कि नहीं मूवी? बाहुबली नहीं देखा तो फिजिक्स नहीं होगा, पर देख के आना. ठीक है, ओके. So horizontal range means how far will it go? Horizontally, how far will it go during the entire time of flight? Horizontal range means what? The net horizontal displacement of the projectile. Net horizontal displacement of the projectile during the entire time